One thing I want to understand before we go into the practical aspect is, what is Wireshark itself? You know that Wireshark is actually a packet sniffing tools that we are using to analyze packets. Or let me just put it in this way: is like let me say, it is what we are like using to eavesdrop. Like you're trying to know what is going on with your neighbor networks. Do you get it? That's the basic purpose of Wireshark. And like what Ms. Favor said in the last class, they said we use it to intercept networks, traffic, we use it to decode protocols at multiple layers of the OSI model. And like I said earlier, you see this Wireshark, before you can understand how it works, you have to know the OSI model very well. From the likes of physical layer to application layer, it is very, very, very important. And if you are not that deep rooted inside it, there might be some little difficulties in getting hold of this Wireshark. And also, it empowers users to capture, inspect, and deeply analyze network traffic in a real time. Like you're doing something like a real world scenario. Are you getting it?
Yeah.
So that's it. And one thing you have to understand is, Wireshark only allow analysts to discover and investigate the packets in depth. Do you get it? It's only allow we as an analyst to just what? Discover, investigate, and the packets in depth. And one thing we have to understand in Wireshark is, it's not just that you just go there and say, oh, I'm just inside Wireshark, glory be to God. No. What you have to know is, what conversation am I looking for? That's the first question you ask yourself. And the other one is, what should normal thing look like? Okay, is this thing normal for this thing? Is it the normal behavior of this thing, like this network? And the other one is, what is standing out as a strange? Some, like, let me put it this way. Like, you are given an assignment to work on maybe on an attack. You don't just assume. We know that there's something we call zero trust architecture, which is ZTA. But one thing we have to know is, and according to that ZTA, we assume breaches. Do you get it? We assume that, oh, this thing is malicious. But one thing you have to understand also is, we have different types of alerts, the likes of true positive, true negative, false positive, and false negative. Once you are given maybe any system or a user machine to text on, what you first check is this thing the normal behavior of the user machine? That's the first question. And the other thing is, you check through the logs, the documentation, and everything on the user machine. From there, you have to check whether, oh, is this thing legitimate or suspicious? And once you notice the thing is suspicious, that's when you now know that, oh, I have to isolate this user machine immediately. That's the essence of, I'm just using that scenario. That's what we are using Wireshark for. Do you get it? It's just like analyzing a packet. And what did I mean by packet? It's like the data being sent out. That's it. So let me continue. So also, let me just go to this. Everyone can see my screen, right?
Yeah.
So now, if you look at this, my screen very well, let me try and find a way to zoom it. Okay, if you look at it now, there's something we call this thing I click on now. Everybody can see my cursor, right?
Yes, I can see your cursor.
This blue, this blue thing is what we use for what? Capturing packets. You can use it to capture packets. If I start it right now, it will start my capturing. The other one beside it is what we use to what? To stop capturing packets. And the one that follows. Okay, this one is one we can use to restart the current capture. Like the packets we have actually analyzed earlier. We can use this to restart it. And the other one that follows is our captures option. And this our caption option is the one showing our interface with the like of Ethernet 0, Ethernet 1, any loop back. And one thing you have to understand is our loop back address is always 127.1.0.0. I think. Yes, it's correct. And what I mean by interface is like what we are actually connected to, like the network. All this ETH is like Ethernet 0. And you know that normally, that means this Ethernet you are seeing right now is what I'm connected to. There are some people that might be connected to their Wi-Fi to show, but that one will not show on this. It will show on normal Wireshark app. Let me go to that. Sorry. I want to check my Wireshark. Oh gosh. Okay, this is it. Because if you check through my screen very well, you see that I'm connected to a Wi-Fi. This is my normal Wireshark. This one is not inside my Kali machine. This one is my normal one I'm using. Do you get it? You will see that everything showing here is what? It's showing Wi-Fi, Ethernet. Even that means the Wi-Fi I'm connected to right now, I can check the packet. Let me just click on the Wi-Fi now. Let me start packet. See how fast you see. Then I have to stop it immediately. Just like it's not even up to 1 minute. It has recorded 1,146 packets. See. Can you see it?
Yeah.
So now, let me go back to Kali so that it will not be like I'm using outside Kali to explain. But everybody can still understand, nevertheless. So that's the part of. So now let me go to this. You can use this to save the capture file. The one beside it. I don't know why my listing is hanging. Let me just go to file. This file now. This file is, let's assume you want to check. Are you saying something?
No.
Okay. This file now, let's assume you want to check or you want to open. Maybe you have something you save or you have a document you save on your Kali machine itself and you've saved it. You can just use this file once you open it. You open it here. It will bring everything, you see. It will bring everything on your system. So you can just come to this place and type the name of the file name and so on and so forth. That's how that works. Then you can, once you place the thing there, then you open it. I don't want to start capturing. I want to explain all the filters so everybody can understand. Okay. So now you can also go to edit. This edit is where you edit everything pertaining to your Wireshark, both the colors and everything. You can just go to preferences. These preferences now, see, appearance, we have columns, we have front-end colors, we have layout captures, we have expert, and so on and so forth. We have the protocols we are using. So now you can just go to this column. You see, these are the columns I'm using. And what I mean by this column is, if you check your packet, when you're analyzing your packet, let me go to this side so you can understand. What I mean by column is all this number, all this time, source, destination, protocol, and length with info. Are you getting it? This can I proceed?
Yeah, you can proceed.
Okay, thank you. So that's it there. Some people might be in a default way. or it might be maybe in something like -1 on everything. I will explain how you can edit everything. Also, you can go to font and colors. This is where you can change all the colors. Maybe let's say the valid filter, you're using green. Invalid filter, you can change those colors. You can just take your time and play around all these things. It's not that hard. You can also go to layout. This layout now, assuming you see the first thing is packet list. That means your packet list is coming first, your packet details follows, and your packet bytes follows. So you can just choose the one you want, how you want it. You see different layouts is there. You have one that they can follow each other. There is one that one will be at top, 2 will be by the left, and 3 will be by the right, and so on and so forth. So let's also go to, so that was all about that. So as far I'm not doing anything here, I'll just click OK. So the next thing is view. You see, you can use these things to view maybe your packet details and everything. The view of your Wireshark itself. This is where the thing can be edited. So we have other thing we call Go. This one, once we start the packet, is when this one will be showing. And this capture itself, options, we have statistics, we have telephoning, we have wireless, we have tools, and we also have up. So now, let me now go back to this explanation. So the way this is right now. So if you want to maybe create a space between this your dashboard, what you just have to do is click. You can right click your laptop. Right click on that time. Once you right click on it, go to resize column to width. Then from here, you see it is 100. I can change it to like 150. Enter. Can you see?
Yeah.
Also, you can click on source again itself. Column resize. You can change this one to, this one is on 150. You can change it to 200. Enter. I see that there is a space between it. The thing is not jam-packed. So you can also go to protocol. How you want it, you can do it. This one is on 57. You can change it to 120. This length and info are too jam-packed. So you can click on length. Resize column to width. I can change this also to maybe 100. Enter. You see, everything is working fine. So now, you see that my home now, what is showing is this place that I'm scrolling on now is what we called packet list. And what did I mean by packet list? We have packet list here. This packet list. We have packet details. And down here is where we have our packet bytes. So let me start from packet. I'll start from packet bytes and I will go back to packet list and explain throughout again. This packet bytes, I want to find a way and make it show very well. Let me just go to my Kali machine. Yes. So let me just start. I'm trying to start. Oh shit. Okay. This one will be very cool for me to explain. So where you can see all these protocol, length, time, source. This time is the time taken. This source is the source IP address. Are you getting it? Why this destination is the destination IP address? Why this protocol are the protocols, different types of protocol. This one is UDP, which is user datagram protocol. We have the length, and we have the info. And now, this packet byte you are seeing here, is what was sent out initially. Are you getting it? But if you actually want to access this using your machine directly, it will not bring it this way, showing this packet list, packet details. It will just bring it in this X dump. This is what we call X dump and ASCII. You can't understand them. From here now, you see, these are the thing is looking in form of, how will I put it? The way we normally have this our hexadecimal form. These are our 000A. If you are familiar with IP version 6, it's always in hexadecimal. Are you getting it? So this is how it is. The way it is now, you can just click on this like this. You can convert it from maybe, you can convert it to maybe anyone you want. I can say, okay, I want it in ASCII text. Not working. I'm coming. You can convert it to bits. You will see it will change. You see that it has changed.
Yeah.
So these bits now, if you understand, but if you said you want to be doing it this one by one, it will take years before you can convert it back to normal. So that's why we are actually given a Wireshark to analyze it properly for us. This one that you're seeing is like the raw data. So let me now go back to this list. It's just showing us the time, the source, the destination, the protocol, the length, and the info. It is now this packet details that is showing the embedded data we are talking about. And I also like to, like I explained in the call yesterday, for some of others that are not there, I explained what is called packet structure, which is header and payload. And what I explained about header is like our control information. The header contains the metadata about the packet, maybe such as the source and destination IP address, the source and destination port, the protocols, the flags, and the flags are the likes of synchronization, all this three-way handshake. That's the flag. We also have packet length. Can you see the length here? This is the length. This packet length here. This one I'm on. This is seeing 166.154.889 and likes. We also have time to live, which we call TTL. How long will it take to survive? Do you get it? That's the TTL. We also have, and what I want you to understand about headers is, it is the one telling us like how the network is going to deliver the packet. That's the procedure or the main or primary assignment of header. We also have what we call payload. Payload is the data being sent out. And like I said earlier, the data we are sending out earlier is what? Is raw data, and it's in form of XDump and ASCII, which are pretty much scrabbled. If you see, you can't understand, they are jam-packed. Are you getting it? So now, the payload is the only one that contains the actual content that is being transmitted out. With the likes of the file transfer, we have the encrypted top-level system. Like I mean the TLS data that is sent out. We also have the DNS lookups. We have web requests with the likes of HTTP, and we have the application messages that are coming in. So that's just the difference between the header and payload. Did anybody have question, or I should proceed?
Are you confused anywhere? You can just indicate. Okay, I think we are good to go. Okay, Victoria has a question.
All right.
Victoria, unmute your mic, please.
Please, can you explain the payload again? Sorry, I didn't get to.
I said payload is like the data that is being sent out. Are you getting it? Like the data you are sending out initially. That's the payload. And it contains the actual content, like the initial content that is being transmitted. That's what is called your payload. Do you get it? and it contains your file transfer, your encrypted TLS data. Because if you look at this data that is being sent out, which is the packet byte, you see that it is looking like something encrypted, right? You see the hash key, or the way it is. Do you understand it?
No.
So that's the essence of that. That's what we call payload. Are you getting it? So it is not the header that transforms it back to control information, where you can see the source, destination, protocol, length, and info. So that's just the difference between header and payload. Do you get it right now?
Yes.
All right. Welcome. So I proceed. So, and there's one thing I want everybody to understand is with the service we are using, the reason why you cannot access maybe other traffic except the one within your Kali machine is because we are not in what? In promiscuous mode. What I mean by promiscuous mode is like promiscuous mode is the one that allows you to read data or packets from other devices. Do you get it? And you can end and disable it. Maybe after the class, you can just go to your settings. There's something we call network. You can use two. There is one you see adapter 1 to 4. You can just go there. Let me just show you that. Okay. You see, I'll just go to settings, network. You see, I'm using this my adapter 1. Okay, this is my adapter 2. NAT. I'm using NAT in my adapter 2. I'm using this. So this one, everything outside my Kali machine, I will be able to read the packet. And you see this promiscuous mode. You see that I allowed it. You allowed all. You see it's showing allowed VMs, which is virtual machine, deny, allow all. That's just the 3 options there. So there, after class, you can just play around this. Okay. So let me go back to okay. So now, let me start from here. So I want to ask this question now. This is where our understanding on OSI models comes in. You see, we have our frame, we have Ethernet, we have internet protocol, we have user datagram protocol. This frame, which of the OSI model is working with this frame? I want anybody in the group to answer the question. No one?
You mean this frame one that you just opened down?
Who can explain this frame now? It is working on one of the OSI model. Which of the OSI model is this frame working and why? With a good reason. And why is it needed?
I think it's working on the TCP.
No. You know that TCP is not among the OSI model, right?
Okay.
It's on the physical.
Why do you say it is on the physical, sir?
Because that's where you build everything.
Frame. But I don't think this frame can actually be on physical.
Okay.
You know that if you remember when they explain what this physical layer is for us. They say is the one that manages cable and signals. Are you getting it?
Yes.
And which is like all these our what's it called? Raw bit transmission over physical medium. That's physical layer. But thanks for the people that actually answered. But now I would like to explain the layer this frame one is working on. Or I just want to make an instance, but I will see whether anybody can also. You know that they said data link layer is like MAC addressing. Remember during our classes then, they said it provides node to node transfer and delivery using MAC address for local delivery and also create frames. So now this frame one is working on which OSI model?
Data link layer.
Thank you very much. And the reason is that this frame is actually a specific data being sent through a layer, which is called OSI model, like I'm saying, which occurs on data link layer, like what you also said. And the reason is that it's the one that is making our computer to communicate through a switch. Are you getting it? Because you know that if you look back at your networking, if you connect end devices to your switch, you know that you cannot just connect your end devices to a router directly. You have to connect it to something which is a switch. It is now after sending the signal to a switch, it is now the switch that will now send it to the router so that you can access it remotely. Are you getting it?
Yes.
So it has this frame that will make our computer to communicate to a switch to other computer, which will allow our internet connection. If you look at it, you see the interface ID now. It's showing that I'm on Ethernet 0. Encapsulation type. You see UTC time, the time it arrived, the time shift. You see the protocol and everything. The frame length, the capture length. This is working on data link layer. But I want to ask another question. Let's now assume this thing is not a frame. The way it is frame one, let's assume it is now packet one. Which OSI model with that packet works on? I want to see whether you are following me. Is there anybody I want to try?
Please, can you come again?
I said, you see this frame one that you are seeing now. Most cases, you might not see frame one there. You might maybe see packets. Then they will give you the details under the packet. Under which of the OSI model did that packet works on?
I think it's still on data link layer.
Why do you think?
Because, like you rightly said, it is the data link layer that controls the node-to-node data transfer, which utilizes the MAC addresses, including the frame.
But you are actually right. But it is another scenario. I will let you understand something. I said data link layer is like node-to-node delivery. But you have to go back to transport layer also. You know that they said, okay, which one converts frames to packets?
Is the transport layer.
It is what?
The transport layer.
Thank you very much. So if you have packets here, that means this frame has already been converted to packet already. That means the packet is working on what? On transport layer. It will not be data link layer anymore. Because the frame is working on node-to-node delivery, like simultaneously. But now that transport layer has converted it from frames back to packet, not from packet to frame. It's from frames to packet. Do you get the logic?
Yeah.
So that's just the difference about it. So now, let me now go to Ethernet. I'm sure everybody know where this, okay, let me just, the way we see everything, you can just right click again, then you collapse substrate. We are out. Then you click on Ethernet. So this Ethernet now, who can tell me which OSI layer this Ethernet is working on?
Destination source. Is it the network layer? Network access layer.
Are you guessing it?
I'm trying to look at what is there, the destination source.
Just look through it again and see which of the OSI layer can it works on.
I think it's the
Is it
network
application layer?
No, it can never be application layer. It's not application layer.
I think it is network layer.
Yes, you are right. You are right. You are right. I just see one thing is, you see, one thing is if you know or you understand something, and if they are trying to convince you, they want to know how bold you are. Do you get it? So whenever you are maybe doing there was one time I was doing an interview. When I was recording it, I was not like, see, whenever you are doing an interview, don't say I think. Do you feel it? Maybe you are not up to the task because you are going for an interview that they will give you a job. You are telling them, I think I will be able to. That thing is a red flag already. You will say, I can. Do you get it? So that's why I'm asking you, are you sure or you are doubting? You are correct. It is network layer because it's the one that handles the routing and IP addressing.
Yeah.
Do you get it? And it's also determining the best path for data across network. Do you get it?
Yeah,
so that's it. And also, I would like to add this one. The packet I talked about the other time too. Most cases, it can also work in network layer also. Do you get it? It now depends on the kind of maybe protocol that is being given. If you are seeing the like of TCP, UDP, then that means you know this thing is working on transport layer. But if not, then we can say it is working on network layer. I hope everybody is understanding, please.
Yeah.
Yes, we are following.
Okay, thank you very much. So now, everybody know where this internet protocol works on, right? Oh, I'm coming. You see? Where is IP working on?
You
say that again, please. What did you say?
Internet protocol, this one, is on which OSI layer?
Network layer.
It's on network layer. Network layer.
Exactly. That's very, very correct. Thank you very much. That's very, very correct. So this Wireshark is not real. You see this data now. This data is just, if you see, nothing is there. I think now I've been able to explain what packet list, packet byte, and details is. Do you have any challenges with it, please? Or you are okay with the way I explained it? If you have any question, you can also ask now. Do you get it? We don't get any part in it, so we can reframe it again or we can go back to it again. Or if you feel like you are good, just send thumbs up. I beg you.
Please, I have a question.
Okay.
How about you have explained transport layer, network layer, and data link. How about application layer and how about application layer?
You see, if you look at the way we are being explained to, they said application layer is one that provides network directly to the end user. And with what you see now, you see the details we are seeing there. You are not seeing anything related to maybe application layer. Are you getting it? Most of the thing, if you check it, most of the thing we actually focus more on Wireshark. You check it. It's either it is maybe our network layer, transport layer, and data link layer. If you check the OSI layer, you can go and check it very well. Most of the places where people can maybe attack you, it is the data link network and transport, because there's no way before you want to do anything, you have to pass through those three. Are you getting it? So I'm just using what is on the packet details to explain. So if you understand this OSI layer OSI model very well, if you see anything related to maybe any info or details that is being given, you'll be able to understand, oh, this thing is all actually working on the data link layer. Are you getting it? It is when you enter SOC now, you will understand the reason why Wireshark is needed. Do you understand?
Yes, I understand.
Okay, thank you very much. Any other question, please? Or I can proceed.
Well, Mr. Emmanuel, thank you so
Yes, sir.
much. Sorry, I joined a bit late because I've been waiting for the link, but immediately I stepped out before I came in. You've already started. I didn't know how you captured the packet. This is one of the aspects that I have been having challenges, because the other day Ms. Favor taught this particular course. I was following up, but along the line when she now brought a link, that HTTP forward slash testers fullweb.com. Immediately they clicked that link, and then they brought the password using the the username being anon/anon. Once I imputed mine, I got stuck there. I couldn't proceed. So everything that was done, I did not follow up. And today again, when I came in, you've already captured the late data. Or sorry, the packet. How do you capture the packet and then before you start analyzing it to this point?
Okay, thank you very much. You see the one I captured now is just my own Kali machine, outside my Kali machine rather, which is outside. I've not even checked through the one Miss Favor spoke about the other last time. But I'm still going there, but I've not talked about it at all. I'm only explaining the basic, like the dashboard, the structure of Wireshark itself, what Wireshark is embedded. Like, do you get it?
Yeah.
So that's what I'm just explaining currently. What is packet list, packet byte, and so on and so forth. That's what I'm working on. Do you get it?
Yes, sir.
Okay, sir. So I will
Thank
go
you.
back to that right now.
Okay.
Any more question, please, before we proceed?
Please, yeah, like the other day, I tried capturing data myself, and I discovered it wasn't doing anything. So I tried capturing outside my Kali machine. How did you do that?
Were you able to capture outside your machine?
No, I wasn't able.
One thing is, like I said, if you're in the call before, I said you can do the settings on your network. If you go back to your settings, but before you can do the settings, you have to switch up your Kali. Once you now switch it up, your VM machine, and you now go to settings. You go to these settings. Let me show you. You go to these settings now. You see my Kali is running. I have Ubuntu. I have server. So you just go to this your settings. Then you go to your network.
Yes.
Network. The network here. Change it to this bridged adapter and allow all. You get it? Either you do this, but you see that we have close to 4 adapters here. You can choose this one because me, I'm using 2. I won't lie to you. The other one, this is it. I use NAT as the other one, and promiscuous mode for my NAT will deny.
Okay.
And this NAT is like network address translation. And what this one is just doing is just like, you know that normally network address translation is like you want converting maybe how would I say your private IP to maybe a single one public IP. I don't know if you understand what I'm trying to explain about NAT. But if you look at this bridge adapter, it will give you full access to capture traffic from outside. But NAT is just within, like inside. Are you getting it? It's like NAT is inbound while bridge adapter is outbound. So you can do the settings here. And if you do the settings and you try to capture, I'm very sure it will work.
So Emmanuel, mine adapter type here is Intel Pro. So I have to change it to.
No, change it.
Okay, no wonder.
You can change it now and try something. You will see the difference. So let me go back here. Oh, geez. What's this? Okay. So this is not the one Madam Favor gave to us. This is just my own normal one. You get it? So let me try and maybe continue without saving. Okay. So now, oh, I should have stopped. 1,500. This is too much. Okay. I want to use that Madam Favor own. So let me do it this way. I launch new instance. Exacto. So since you're working on Ethernet 0, what you just do directly is go to this your via Mozilla Firefox. Then once you click on it, are you following? Once you click on this, I don't know what's going on. It should have been working. Okay, it's working. So now, come. Okay, you see, I already have the test this thing. What you just do is, I know that the day that a lot of people are having issue because they are not pasting the link on this place. They are pasting the link on what you want to know more about Kali. That's why a lot of people are pasting it. Am I right? Okay. So you just paste it here like this. Where you have this, then this. You see? It will show you this. I hope everybody can see my screen, right?
Yeah.
So you now go to this login. This login now, you now go to that. Let me go to that, Madam Favor, this thing. I'm coming. Okay, this is it. Walk through. Okay. All right. So they said we are here already. Just copy this password. They said we should use anon/anon as username and password. Then you copy it. Once you end up copying it, then go back to your Kali. Then you paste it here. Control V. Are you getting it? Then you paste same thing here. Control V. Please, are you following?
Yes.
Thank you. After you've done this, make sure you are ready to capture. Then you click on login. After you've logged in, I'm coming. This one is okay. Then you click on capture. Oh,
Okay, I thought you were supposed to start capturing before you log in.
I'm coming.
Yeah, I wanted to say the same thing because according to Miss Favor, I said we should start capturing before we log in that day.
Please, I'm coming.
Okay, all right.
Ethernet 1. Okay, let me use Ethernet 1 on my own. Okay. it will not work that way. It cannot work that way.
Okay.
Because the reason why I tell you is, let me go back to this place so you see what I'm talking about. Okay. This is what I want to show you. You look at it. You see that the thing is, this thing that you are seeing is showing that the thing is already, you see, I have close to like 3 that are already reading. So
Okay.
if you click on this thing, even without doing anything, the way it is on this Ethernet, because what Miss Favor used the other day, it was Ethernet 0, right?
Yeah.
Yes,
And now
it's Internet 0.
you see that the thing is already showing. If I click on this thing right now, it will work. It will start capturing packets. So now let me do it the way. Okay, you go to this. And now,
Please, can I say something?
please, you can.
Okay. Because I think the purpose for us to start capturing before we log in was that, according to Ms. People's explanation, was that when you start capturing and we try login, then the login will be, the capturing must have started then. When we log in, it will now capture the process of synchronization. That a three-phase handshake will be able to trace it in between those packets and know the person that wanted to access that period. I think that was the explanation, the way I understood our explanation that day. Immediately we log in, though the login details are invalid, the packet will capture it, and every other thing that the system will capture automatically according to, and I tried it, it worked that way.
No, okay. It's actually right. But what I'm saying now is that, you know that, because I have like close to 2 people that said when they did it, it's not showing the way Miss Favor own is showing. Did your own show the way our own show, right?
It
Yes.
showed this morning at first it did not show, so I had to close the Wireshark like 2 times and restart it again on the Kali Linux before it now captured the way she did it that day. Even on the when I tried to do the Kali Linux this thing, and there was a time that I did not show according to what she's network. I don't know. I had to start doing it all over and over again before it's now reflected the
Because I
way
won't lie to
she
you.
captured it.
Myself, I've done it that way, and it was showing exactly what ours was showing.
Uh-huh.
Are you getting it?
Maybe it is network. Maybe it is network. I don't know. I don't know why. But sometimes it did not show on my system until I got convinced. I was now closing and closing and closing and restarted again before it showed properly.
Okay. I don't know why I'm having issue.
Good afternoon, everyone. Hi, good afternoon, everyone. Can I say something?
Yeah.
Sure.
Good afternoon.
Okay. Sorry, I joined late too. I'm just coming, but I'm looking at what is trying to log in. That unknown. I think when I was watching it, I think Miss People only put unknown on the username, then another unknown on the password, not
You see?
unknown/unknown. I don't know. Maybe you can try it like that and see how it works.
Okay,
Yeah.
she did not use anon/anon for this thing.
No, she used unknown, then another unknown for the password, not unknown/unknown. Do you get?
Thank you.
Then try to clear the browsing history on the Firefox. You use a fresh.
So you mean she used username as unknown and she used password as unknown?
Yes.
Yes,
Yes.
yes.
Okay. You mean this?
Yeah, something like that.
Okay. I'm coming. Whoa. 29,000. I'm the one that did the setting this way,
Okay.
but I will change it so that it will be slow.
And again, immediately you click captioning, it won't take long. You log in and you stop the captioning. If you leave it for long, it will capture too much.
You see my own, the way I did the setting. Even though in 10 seconds you can capture 30,000.
Okay.
But I was actually going through the settings on Wireshark. That's when I did it that way. I will change the settings after the class.
Okay.
Thank you.
Okay. Those of you who are just coming now, we have done a little fundamental, and we get our head straight. Some questions were asked and answers were given. So I think you have to wait for the recording to be dropped so that you can go over it.
Don't let me use this and waste people's time. Do you get it?
Okay.
So after you've put or placed the password she gave us and everything there, and you log in, do you get it? And the reason why you're saying it that way is, but this is the process of logging into that file. But if I want to use the manual form, you can just go to this file, you open it, and this is it. I think everybody understand how she copy everything on Kali, or I should explain that too.
I think we all got that part. Is anybody having any difficulty how we downloaded this sample pickup?
Yes, so please explain.
Okay. All right.
People are
Okay.
having this with it.
US official is raising his hand. You want to say something? UPS. Okay, Mr. Emmanuel, I think you just explain it over. But sometimes it's okay, you go over recording again. It's really happened. It's really happened. The link to download that. Mr. Emmanuel, just move further, please. We'll attend to you in the group. Let's minimize this our time, please. I'll attend to you in the group. The link is there on how to go about that.
So you just click on this sample, then you click on open. Then you start packet. I stopped it. Can you see it? This is showing the source, the destination, the protocol, the length, the info, the real-time transport. And let me explain this. The reason why you see my own showing different from this way is the way I set my network. I set my network so that I can see packets from outside, not just within the Kali. You see the way Miss Favor showed our own showed, right?
Yes.
If I said I should off my Kali machine now and change it to that network address translation, you will see it exactly the way as is. Or if you want to try it after this class, just try and change that your NAT to bridge adapter. You see that it will never bring the way that Madam Miss Favor own brought. You will not see the way that the way Miss Favor own showed in all those HTTP and things. You just try and use that bridge adapter. You see that you will not see same thing. After this class, maybe 2-3 people can try it and send the result to the group. You'll be seeing something like this also. Because me now, I'm on bridge adapter. I'm not using NAT. But we are using network address translation. It will capture what is within your system. But now, what my own is capturing something outside. Do you get it?
Yeah.
So all right.
So that's
okay.
You're saying something, sir.
No, I said understandable. Since it the end product is still the same result it will give. The same packet, the packet details, it will still come out that same way. But I know that you advance your own stuff.
Yes. But if you want to do it, you can just play around the two. Use bridge adapter and check Wireshark. Use NAT and see what will happen. Do you get it?
Yes, all right.
That's just because if you are doing real life simulation or real life scenario, you will not be using NAT. You cannot see result. You have to use from outside so you can capture traffic from outside. Like if you are connected to maybe someone Wi-Fi now, or you want Wi-Fi for someone, and people that are connected, you want to check their packet, what is going on. What you just need to do is to change your Kali machine to bridge adapter. It will show your Wi-Fi. See, this is my normal thing now. Let me show you. You see? I'm coming. I want to try and cancel this. Oh gosh.
Hello, good morning. Please, can I ask a question?
Yes, ma'am.
Okay.
So, I don't know, this second method, Miss Favor mentioned something about, she said there were two methods we could use to actually navigate, or there is one that you can import, like there is, wait.
That's if you have a packet that has already been sniffed, how to open that, right?
I'm sorry, there was noise. Somebody was making a call. So the second, from what I want to understand, the second method, is it what she was saying that most times you're not the one to capture the package yourself. A company can actually just like send it to you for you to upload and capture the packet. So this second method, is it like what she was explaining to us?
Exactly.
Yeah,
Yes.
it's what he's
Okay.
trying to do now. Yeah.
Okay, thank you.
I want to open my normal Wireshark and explain what I mean. This now is not on my Kali machine at all. Can you see that I'm connected? If you check my laptop, I'm connected to a Wi-Fi, right? So if I click on this Wi-Fi now, it will be showing me all the packets. You see, it's showing the IP address. Do you get it? Let me just click on this now. That's what I want to check. This Wi-Fi. Jeez.
Okay, sorry, let me ask you a question. If
Okay.
if you are using this one, does it mean that you can be able to sniff on every traffic that is every device that is connected to that Wi-Fi?
Yeah, you can. Let me show you what I. Yes. You see now, it's bringing Wi-Fi. But if you check your Kali machine, it's not bringing something like Wi-Fi, right?
Yeah.
So what you just do here is start. Let me start so you see. I stopped. Can you see? So these are everything that is going on. These are everything that is going on within my thing. You see.
Please, I want to ask, do we need to download Wireshark app separately on our system to do that, or we use the same that is downloaded on the Kali?
No. Me, I won't lie to you. Me, I'm just doing research and extra job new, but I'm just trying to explain how it works. Are you getting it? Me, I'm just doing extra. I'm just trying to check one or two how it works. Do you get it? So I'm not saying everybody should now go and be downloading Wireshark app. But one thing, if you still have it, it's not doing any harm to your laptop or your system. It's just for more better understanding about how this thing works. You get it?
Yeah.
So that's just it.
So like this now, if our system is connected to outside network, like a Wi-Fi, we can use the Wireshark on the Kali to capture the traffic on the network.
Yeah, but you have to change the network.
The setting. Okay.
Bridge adapter, and you allow promiscuous mode. Because I explained earlier that there's something we call promiscuous mode. It's one that allows you to read data or packets from other devices. So you can either enable it or disable it. Do you get it? It has enable and disable expression. How you want it, you can leave it. That's when I showed that earlier, that you can allow the VM, you can just allow or you deny, depending on how you want to do it.
Okay.
So, and there's something they call all these logical operator. Those one, I will try and find one of my notes that explain well or more about those logical operator. Because that thing is, I won't lie to you, it's not simple, and it is simple. If you have the mindset, it's simple. Because you'll be saying something like, okay, because if you want to display your filter now, writing something like maybe TCP then equals to TCP dot port PORT. You see the way this thing is showing. That means what we are seeing here is like TCP dot port is equal to 80, and 80 is the port number. You get it? And also they now say and UDP port equals to 80. If I click on this now, let me see whether we have any result. You see, we don't have result pertaining to this, so you don't have to stress yourself. It is only what you can check. Maybe let me check DNS whether it's there. DNS is not there. But there are some packets you will actually analyze. You will have HTTP, you have DNS, and the reason why we are using filter. Oh, before I forget, we have two types of filter. we have the display filter and we have the capture filter. We have the display filter and capture filter. And what I mean by capture filter is the one that controls which packets are recorded during the capture process. Please, do you understand? Capture filter is the entire packet that we are seeing here, like this. Oh, jeez, sorry. Like this. It's the capture packet. But now, you want to now check, like, the display is like you want to check the specific. Like, it will allow you to refine the packet shown after a packet is completed. So now, I can now click on this apply display filter. Now, you can check UDP. You see that it's listed all the protocols that are like, you see, all those ones that are related to UDP. Can you see them? Or let me go to this place. TLS. We don't have any. Let me go to HCP. No. Okay. So, like that display filter, as I'm explaining, is capture filter will only show like the entire packet that is being captured. But display filter is one that will now check, oh, this, all what I want to see is just about UDP. All what I want to see is just about DNS. All I want to see is all just about TCP. That's the work of display filter. Do you understand?
Yes, sir.
And also, I would like to explain the reason why we need DNS, TCP, and HTTP on this our display filter. DNS, the reason why we need DNS is because we use it when we want to see domain lookups, like domain name lookups, how to confirm whether names are resolved correctly. That's the work of DNS. You know that according to the universal domain name system, right? And we also have TCP. The reason why we are actually typing that TCP on our display filter is we use that one to focus on the connection behavior, like our section setup, like the retransmission and transport level traffic. You get it? And the reason why we need HTTP is there are some times when we are reading maybe some web traffic. This one is now the HTTP will now allow us to insert request and response from end users. You get it? So that was just the difference between DNS, TCP, and HTTP. And there are some times if you want to maybe check the personal, maybe one specific IP address, now that we use something like IP.addr. The reason why we use that is we are using that to just isolate traffic going to and fro, like from one specific system to the network. That's the reason why we normally use that IP.addr equals maybe 192.168.1.50, 192.168.1, and so on and so forth. So that's just the difference between those DNS, TCP, HTTP, and IP.addr. That's just the difference between them. Does anybody have any question?
Is there any question in the house? Okay, I think we should just go for them.
Oh, do we have Mr. Abubakar in the call?
Yeah, I think it's
Yeah.
it.
How are you doing, sir? Please, do you have maybe any like addition, subtraction, or multiplication to these things that we have actually said
All
this
right,
day?
I can add a little.
Okay.
Let me turn on my screen first.
Okay, all right. Okay, Mr. Emmanuel.
Yes, sir.
So while Abubakar will be presenting, you will be preparing the project we talked about. Yeah, we'll see how we can converse it.
Okay.
Yeah. Okay,
My
Abubakar.
mind is not even in today class like that. Let me just stop.
Okay.
All right, I just want to piggyback off what Mr. Manuel has said, considering the filters and also about this website. I noticed that some people are still having issues understanding what was going on. So, first of all, when you paste the website in your Firefox, you can start capturing. I think it's easier to start capturing before logging into the website. I think it's, let me just close mine and then start all over. So start capturing. Just wait a bit for some packets to be. I will reload the page. Okay, it has already started capturing. So now we can log in. There's something I want to show you guys. Once you log in, it will give you this invalid login response. That's normal. When you stop capturing. If you notice here, okay, not here. Where is it? Sorry, let me retry. And stop capturing. All right. If you notice, when I started, there are a few black lines. And there is one particular black line that says HTTP protocol, TCP previous segments not acknowledged, post. This particular line with the HTTP protocol response shows the direct instance or direct packet in which when you clicked on login, what was going on in the back end, this particular, you know that the website is not secure. On a secure website, it would be a HTTPS protocol being used and you will not be able to see what is going on. But once you click on this, I don't know if you guys have the same thing, but this is just a little example. Once you click on it, a little tab will show here that says HTTP form URL encoded. If you drop down on that, you will see the username and the password that I entered. So this is a way in which attackers, when they know or when they give you a website to click, like all those fake bank login websites that they send with phishing links and stuff, if you by mistake enter your username or your email and you enter your password, they can go to their packet tracer. Sorry, they can go to their Wireshark or any packet analysis software that they use and identify that username and password that you clicked, just as it has been shown here. So that is the tricky thing when you are on a website that is HTTP, not secured, as you can see here. If you're on any website, be very careful that you are not giving any of your personal details, because the people that are on the back end, they can see what you are typing or what you are sending in and taking out from their website. So also on these filters, from the LMS, mine is not open, but if you open up your LMS and you check the cheat sheet that she provided, there are different filters that you can play around with. Like if you want to filter out HTTP packets, just use the HTTP filter. If you want to filter out any other packets, you go to the protocol, you can type the name, let's type ARP. So this can just help you to, if you are looking for a specific thing in your analysis, you can use these filters for that. The same thing goes with our IP addresses. If you are trying to filter out specific packets being sent and being delivered to a specific IP address, you can just type IP.addr equals to then whatever the IP address is. An easier way to do that is to hover your pointer over that IP address, whether it is a source or destination, right click, and then go to apply as a filter. You'll see that it brings out different options, but the only one that is available is selected or not selected. If you click on selected, it will highlight that specific address when it was a source. That means when it was the source of data packets being sent to a destination, it will show you that particular IP address. So that's basically what filters are used for. And then all these other tabs above, you can use them. You can just play around with the packet tracer. It's not as hard as it can be, but the first thing you should know, if you want to just do a test on yourself or just give yourself a little practical, you can search up websites that are HTTP. You don't necessarily have to use the one provided by Mrs. Favor. You can just search here. I think I've used this bad SSL before. This HTTP forever, it's not one. So you can come here, you can, let me just write anything. And then password. And when you click, oh, I've not started capturing. Sorry. So you can just go to the website. And then back to your packet tracer. And you can trace that particular instance. Okay, I didn't capture enough packets, but that's just it about Wireshark. You can just play around with the interface and do some experiments on your own and just get conversant, especially these Frame 1, Ethernet 2, Ethernet protocol, and transfer protocol, or just get conversant with what they do and study more. I think Mr. Manuel has already explained these frames. He has already explained Ethernet and Ethernet protocol for they are on the network layer. These frames is on the data link layer. But it's not just about understanding why they are on that layer. Understand what goes on in that layer, so that when you're looking at all these things that are under here, it will not be confusing. The encapsulation type, Ethernet 1, the arrival time, the epoch arrival time. When you just, if you are confused, you can just ask, what does this specific thing mean? How does it work under the data link layer? Same goes for these that are under the network layer. How does this source IP use this MAC address? Like, just get yourself conversant with it, and it's not that difficult to go through. I think some people may have DNS under their protocol. If you click on it, it will bring out different sub-menus. Like for my TCP, it's brought out a transmission control protocol sub-menu. If I click on HTTP, to bring out a HTTP sub-menu. This one just defines how the website was built, the CSS and the HTTP that was used in building it. So if you are trying to edit it, and there's TLS as well, transport layer security. So that's just it from me. If you are still having issues with capturing packets and logging in on this website, you can go to this one that I have gone to, bad SSL. You can just go to this website and try doing the same thing. The main idea behind it is that it must be a HTTP, an unsecure website, so that you can know what's going on when you are clicking on login and how attackers can identify your login info. And about this length, I think Ms. Favor also explained that usually this length should have fixed values that correlate with one another. Like, remember, and the lengths are in bytes, by the way. So let me just give an example. This first frame is 400 bytes. Second frame is 800 bytes, 66 bytes. But let's say you can see that the values are a bit constant between themselves. But let's say you now get a value like 3,000 or 5,000. If you are working with database systems where if you are an attacker and you want to exfiltrate a lot of data from a website, you'll be seeing byte sizes that are very high. So if you are a network admin or a network analyst and you are using your Wireshark to do maybe reconnaissance or just monitoring the network, and you now notice something like 20,000 bytes under the length, that should already give you an instance or an idea that something is going on without the knowledge of anybody. So that's just another benefit of Wireshark for defense-minded cybersecurity personnel. They use it to verify and check if everything that is going on in the network is well and fine, or if there is any malicious attacker in between these packets, because they are very important. So that's just it. There's not really much to go about it. Mr. Manuel has already given a very detailed explanation that is very easy to understand, and I hope everyone is okay. And if there are any questions, you can raise your hand.
Sorry, I want to ask a question.
All right.
Now, we have the HTTP protocol and the HTTPS. So when you are sniffing the data from these both protocols, what are their difference? The HTTPS I know is secured, while the HTTP is not secured. From this HTTP now, we are able to see the user password and username or email, whichever one they use. So if I am working on the HTTPS, with something like that, will such how will I call it? With such
I get what you're trying to say. Don't worry. Let me just practicalize it. I understand your question. Whether it will show. Let me look for a website that is common. Okay, let's go with.
Okay.
I still have to log in with my. Let me see if there are any HTTPS testing logins.
Okay.
This one is secured. Network should not be the downfall. All right. So this is a secure website. Let me clear these packets. Oh, stop. The website is still loading. Okay. So the website is having some issues. Sorry, give me a moment.
All right.
Let me just pick it back up, please. Let me even just use the TS Academy portal. I think that one will be easier.
Okay.
But usually, when you are using a HTTP, when the website is secured, if you go to that drop down menu, you would not see it there. It will be scrambled. It will be, what's the language? It will be made in a cryptographic or encrypted format. So once you are now trying to analyze that particular packet with the HTTPS protocol, instead of you seeing the anon, you will just be seeing some scrambled language that you cannot understand, which makes it encrypted. That's secure part of it.
But it can be decrypted, right?
Let me try logging in. Let me try logging in. Restart. Let me close. All right. Okay. I started capturing. Let me just put any password to bring in error. Stop.
That one that you wanted to wear yesterday.
Captured a lot of packets. It's reduced. This is one of them. The TLS, Transport Layer Security. It is encrypting data under the hypertext transfer protocol. So if you notice, it's TLS that's mostly here. TLS 1.3, 1.2 is helping with the encryption. So naturally, this is one of it. Encrypted application data. You can see this long string of text and letters. This is one of the packets handling the encryption of every detail that you are using on that secure website. So even as I entered my email and I entered the wrong password, you cannot know what I entered because it has been encrypted, this long format of text. So that is it there. That's what happens when you use HTTPS, which is a secure website.
But sorry, I want to know something.
Well,
when we started the class earlier, Ms. Favor talked about connecting over in an open source Wi-Fi. That's a free Wi-Fi.
yes.
That an attacker can monitor your transaction from your connection and probably monitor your password and whatever.
Yes.
Is it not this Wireshark that they use for that? Because if this thing is encrypted, which means there's a way they decrypt it.
No, they don't use Wireshark. They use Nmap for that.
Nmap.
Yes, Nmap. Mr. Manuel talked about it yesterday. They can use the Nmap since it's an open source Wi-Fi. They can use Nmap to sniff what is going on in and out of that Wi-Fi. That's another application on this thing. It's another application on Linux.
Okay.
It has its own.
Okay, Mr. Emmanuel, I want to say something.
Okay.
Okay, like what he's actually talking about. You see that Nmap, like what I said yesterday. You can only use Nmap to sniff, like what he said. But if you by chance see an open port on those, maybe the account you are trying to sniff on, you can, it is only before you can use all those tools perfectly, you have to be given a legal right to work on it. It's not that you just go and check out someone else's account and you feel like you want to sniff inside it. Do you get it? But the one I'm using yesterday is just normal. Do you get it?
Exactly.
Because the way this Kali is working, if you are trying to attack, they will know your location where you are. And like I said, I'm not saying everybody can do it, but the only thing you can do to maybe all these attackers, the way they do theirs is they will not use their direct laptop. They will not use the Kali on their machine to attack. Either they find a way to download maybe a Kali machine or another machine inside maybe an external drive. So once you log in on your system with that external drive, you know that they cannot maybe get the exact location of the external drive. Am I right, sir?
What do you say?
Like what I'm trying to say is this Kali of a thing, like the way this attacker used to do, is that they don't use it directly, because if they are trying to use it to attack, those in charge of that Kali Linux, we actually see the location, precise location of the person tampering someone else's account. And I said there are some way. I'm not saying we should do it. We can get an external drive and download that same app.
Yes, exactly. There are USB drives that you can program with operating systems and specific applications.
Exactly. They will not get your location. But I'm not saying we should go and do it. Because if you look at it, maybe few months ago, they said there was one guy that scammed maybe one country like that because he was using a Windows. So that Windows he used, they were able to capture where he was actually operating from, like his precise location.
Exactly. Because the Windows has the IP address, the MAC address, the network is also using, it may not be encrypted. So there are so many ways that defense organizations can come into your system. They don't necessarily need you to be somebody that is living in the same country as them. As long as you are on a network, you are on a system that uses that network, and you are not someone that is well secured or private enough to defend yourself, they will find you.
I want to show you something. Okay. Like I said earlier, you see, this is my Kali Linux now. And this is my Wireshark now. But he has explained everything. But I'm just showing you this. I switch my Kali machine back to NAT. If you go and use that bridge adapter, the way the thing will be loading packets, you'll be shocked. Mr. Baka, are you using NAT or you are using bridge adapter?
I'm using bridge adapter, but my transmission, this thing is denied.
Oh, you denied it?
Yes.
Okay. Because assuming you allowed all, because the way my own was bringing like close to 2000 plus is because I allowed all. Because now I'm using this NAT now. You can see everything like it's looking according to maybe that misfavor one. Can you see it?
Yes.
So that's just the difference about. That's why I said most of these things you can maybe self-taught, like learn, try and find out, oh, why is this thing here? Check it and find a solution to it. But he has actually explained more. And I think everybody is able to understand how this thing works. But don't try and use Wireshark to attack, or because we did some
monitor network that you are not allowed to.
No, they will arrest you. Okay.
Okay, it's a good one. The thing is that it seems as if you guys did not get my question right. What I'm trying to understand is if HTTPS is as secure as it states, how come that an attacker can still get someone's password?
Let me tell you something. I'd like to. I know Mr. Abaka will say something about it also. You know that before we all believe on firewall, which we have, and under those things, we can actually be talking about all these HTTPS, because when we see that HTTP was not secured, we started using HTTPS. But like what you said, even though you use HTTPS, there are still a way this attacker can manipulate and enter your account. That's why they now say firewall now have stages. With the help of, they say we have one. We have the first one we have is packet filtering router. After that, we change to application level gateway. After that, we change to circuit level gateway. And the one that we are using currently, that's one Madam Favor, or that's one Miss Favor called I think that one is future. I don't know how she called it, but that one is hybrid firewall. It is like the current, like the future generation firewall. And when we see that, they say people have moved from firewall now. They now move to what we call ZTA, which is zero trust architecture. Because they feel like, some people feel like, oh, if something malicious enter, let me try and check everything whether it's working well. But this zero trust is telling us that after this, guys can go and research more on zero trust architecture. Even before anything comes in, think it in a way that this thing is a breach, or it is a breach. Do you get it? Don't assume and say, oh, it is my brother that sent it to me. It is normal. Assume the thing first that it is a breach before you do research on it. Do you get it? There are some HTTP stuff that you will see and you feel like, oh, it is secure. And by the end, you see that you are being hacked. Do you get it?
Yeah.
So that's why you see all these things have stages with the likes of virtual private networks. Do you get it?
So just to add to what Mr. Manuel has explained, let me give, I think we have not done cryptography yet, but cryptography is another important thing when it comes to securing passwords and securing environments online. So your question was that when, even though that the attackers can still see that encrypted login attempt from you, there is something we call cryptographic hashing. On our systems, passwords are not stored the way they are. Like when I wrote that anon, you saw it as anon. On systems, or on databases rather, passwords are stored in a cryptographic hash. A cryptographic hash is a way of encrypting and changing the way something is. So let me give an example. We know what Morse code is. During the World War, there were different cryptographic techniques that different countries used to make sure that when they are sending radio signals, other countries cannot sniff or listen to what is going on. So, for example, now we have two common cryptographic hashing patterns, which is MD5 and SHA-256. For our passwords, when we type in our password for the first time, a database that is used on a server can be using the SHA-256 hashing algorithm. So let's say your password is 2025. Let's just say 2025. Your password is just 12 numbers. What the database is storing your password is not as 2025. It will use that hashing algorithm to store your password in a completely unbreakable way. So instead of you now seeing 2025 on the database, you'll be seeing something like 44A, 23C, 99B. It will just be in a way that is confusing. So the way that database now recognizes your password is the next time you are typing it in, it will use that algorithm again to change your password. And if this thing encryption is the same as what the database has, it will say, okay, you have successfully logged in, you use the correct password. So when attackers now want to see what's going on through HTTPS, they will see that cryptographic they will see that encrypted password. They will not see the 2025. So it is now up to them to now find out which algorithm is the server and the database using. At what level, even though they are using these algorithms, there are still some other settings you can do all these algorithms so that it will be different from other people that are using that algorithm. So what the attacker will now see is, okay, this password is already hashed, it's already encrypted, and this person is using the SHA 256 algorithm. What the attacker will now want to try and do is figure out how that algorithm is encrypting your password. Once he can figure it out, he can now replicate it. But if he cannot do this, because this thing is time consuming, is energy consuming, it's the system that will even do it for him. It's not him that will break it. But it requires a lot of mathematical computations. So even as an attacker, you have to be someone that is very, very smart and very, very sharp. But if you are not someone that can do that, they use another program on the system called John the Ripper. This is for people that John the Ripper is kind of outdated, but it is still in use now because we still have people that their password has been the same since the first time they bought a phone. That is where John the user can be used. So if you are someone that your password has always been your name, and John the Ripper is now scanning and he picks up your name as a common password in its database, they have already gotten to all your accounts. So those are the two ways that I know of. You can either use the John the Ripper tool on your Kali to break somebody's password, or you can use the cryptographic hashing algorithm in which the database runs on to break the password. So even as at that, the reason it is secure is because no matter how the attacker tries, it will take him a long time before he gets that password if your password is long enough and well hashed. So that's why they don't usually lean on trying to break into HTTPS systems. And that's why they do stuff like phishing and stuff like mostly phishing. Yeah? But that's just it. I hope that answers your question.
Yeah. Yeah, it answered my question.
All right. If
Okay.
there are any questions again.
Is there any question again, please?